And finally, there's a couple of different approaches for covering your tracks. Neither of these are really forefront in today's technology because of a couple of limitations that have been removed since they were developed early. But they are still interesting approaches to covering tracks in an ethical hack approach. And so I do want to take a moment to show you both of these. So taking a little bit of a closer look at NTFS data streams and hiding within NTFS data streams, I've got a command prompt open here on Windows 7, and I've got a few files in this folder. I've got a couple of text files that are just plain old boring text files that are tiny, as you notice, and I've got something called aspy.exe, which is actually a keylogger executable. Well, that's kind of cool. What I want to do, my goal here, is to hide aspy.exe behind one of these files. So obviously, I'm going to probably pick test.txt. I'll show you what's in test.txt. And there we go. So really nothing there. So what I'm going to do in order to hide aspy within test.txt so no stray administrator finds it or user finds it until I'm ready to use it, is I'm actually going to copy stream from aspy.exe to test.txt, and here's the tricky part, colon, and then a file name. And you know what, aspy, that sounds a little nefarious. So I'm going to call it calc.exe. Why not? Because calc is a calculator, right? Cool. So that works. If we take a look at the directory, notice that text.txt or test.txt hasn't changed. And in fact, if I type it again, cool. It's actually still test.txt. It's still 73 bytes. Let me get rid of aspy.exe. And again, notice that there's just a couple of text files here, test.txt and secret.txt. We'll keep secret away for a moment and just talk about test.txt, which actually contains both the text file stream and the executable stream. So that's kind of cool. But we want to get it back out. We've rehacked or come back to the system. We want our tools back out. So I'll use the same command, but instead of copying into, I'll copy out of. So I'll copy from test.txt colon calc.exe to aspy. And it doesn't really matter file name, but I'll keep it simple there. And then check it out. We've got our much larger file back, which is actually just ready to go and run. That's all there is to hiding files with file streams in NTFS. NTFS, recall, is the most common file system out there. It's been the default in Windows for quite a while, and this is just regular old Windows 7. Virtually any version of Windows since Windows 2000 will work as long as the hard drive is NTFS. You probably want to know what NTFS data streams are. You may have heard of them, and really, if you think about it, they're easy to understand when you know that NTFS, or the NT file system, the file system that stores files on the hard drive, folders on the hard drive, is basically just a database. And a database that can actually have one record entry, so let's call it mydocument.txt. Typically, it's going to have one data stream. It's going to have one chunk of data behind it. But because it's a flexible database, NTFS allows us to store more than one data stream behind a file. You can actually have 2, 3, a dozen, as many data streams as you want behind a single file in the file system. Most tools only will show you the first data stream, or by default will only access the first data stream. So if you can put maybe some nefarious code or some hacker tools in a data stream behind a legitimate file, or a data stream behind a file that you don't think anyone will really notice or care about or delete, well, that's fantastic. That's exactly the kind of way that you want to hide your tools, to hide your data. Fantastic stuff. And it works really, really well with built-in functionality that's been in Windows for quite a while. In fact, originally it was designed because Mac OS actually has stored files this way for quite a while, and by default stores more than one stream in a file. So to be compatible, NTFS really needed that kind of multi-stream flexibility here. So we can use that to our advantage as ethical hackers by hiding different code behind these files. As long as the file's not detected or not cared about, that's great. The drawback, well, there's really two drawbacks. One, it's not as important because hard drive space is large, bandwidth is huge, so moving our files in and out of a system is actually relatively easy nowadays. When the attacker files used to be very large or set off alarm bells or leave a giant footprint on a system, you had to install them, run the tools, and then delete the files, and then potentially reinstall them, pipe them back in at some future point. Well, the bandwidth has certainly gone up to the point where it only takes a moment to really download and install any hacker tool. And at the same time, storage has gone up. People don't really notice a tiny, tiny, tiny tick on their hard drive. 1 megabyte versus 2 megabytes versus 5 megabytes storage. There's almost no one in the world that's going to notice that kind of tiny difference in available storage. Back 15 years ago, yeah, they might have actually noticed that. They might have been concerned that there are files taking up hard drive space. It's just not the case anymore. So it's not as important of a technique, but it is an interesting one. And when talking about ethical hacking, you may get questions around steganography, steganalysis, this technique, or this art and science of secret writing, which is the concept of being able to find a tool that will hide data, let's say the output of a network sniff in an image, a JPEG image or GIF or a PNG, something like that, where this tool actually takes a legitimate file and takes whatever data or executable file, anything like that you want, combines them together in a way that's not visually differentiated between the legitimate file and the file with something hidden in it. So actually, probably the best example of that is taking a fairly large JPEG, let's say a 5 or 7 meg JPEG, which is a lossy storage approach or a lossy encoding technique for photos, taking a binary file and then occasionally changing a bit in the JPEG very, very slightly so that this tool can mark where the file is and what the data is of that file. So merges this binary file, this tool, into a JPEG, stores it in a way that you shouldn't be able to see the difference. Then that JPEG actually contains the tool, the hacker tool. That's kind of cool. And then you can use the same tool to remove or extract the binary file in another location or at another time. It's kind of a neat concept. However, it's not as useful as you might think, really, because if you're going to move steganography and steganalysis tools around on a network as an ethical hacking approach, well, you're moving tools that are going to be equally as detected as the hacking tools themselves. So why bother? Honestly, it's just almost never going to be worth the effort to do. Data might be a little bit different. Hiding data in some type of steganography in a JPEG, something like that, and then moving a JPEG back out of a network or into a network, that might be a little bit more interesting because the data could be super sensitive. They could set off flags, but it's just as easy at this point to do a zip, a password-based zip, or do some type of encoding, or even just build a tunnel end to end. So this practice isn't in as common use, but the tools are still out there, and it's still an interesting thing to explore if you feel like it.